Hey, hey, hey. We're going to start in a few minutes. 1 minute, actually. So can I ask you to move to the presentation area slowly? No? Tak asi ručně. Jen se pomalu začít to hýbat. Ahoj. Can you start moving people into that area? Okay. Just ask them to. Okay. So. Thank you much. Thank you.
Okay, hello everyone. Hello, hello, hello. If I could just get your attention for a minute or two. Welcome. My name is Michal. I'm the group product manager and site lead of this beautiful Pipedrive Prague office. And it's a great pleasure to welcome you all here. It's actually our historically first external meetup in this office because it was quite unfortunate because we have opened this office in March last year, right before the pandemic hit us. So we haven't been able to do any meetups here yet, but hopefully you'll have fun. We have great, amazing speakers lined up for you from Netflix, Pipedrive, Twisto, and STRV. So hopefully you'll be able to enjoy the event after the official part will done. There will be networking, there will be beers, we can network. So if you want to ask any questions, just find anyone with a Pipedrive t-shirt. And I hope that you'll have a great time here. And without further ado, because we are already 3 minutes late before the official start, but that's okay, I would like to welcome Georgi to the stage, who will be your host for this evening. Thank you. I hope you have a great time. Thank you.
Hello? Yep. Hey, everyone. Hey. Or as we like to say in Pipedrive, tere, which is the same thing in Estonian. Let me introduce myself first. I'm Georgi Marchuk, and you might know me from all the LinkedIns and GitHub of the world. you can find me with this username that you'll see on the screen later on. But yeah, you might have heard about me from some previous events. I was a speaker in a few, and it turns out that I'm not really good at it. And yeah, I don't have that many smart things to say. So we decided that I'll be just hosting tonight and kind of guiding others to the treasure that I cannot possess myself. But enough about me. Yeah, as Michal said, this is our first ever event in this space. And actually, this is first ever event that we're streaming here in Pipedrive Prague, if I'm not mistaken. So it's a 2 times first for us, which is super exciting. But at the same time, we kind of expect some issues and stuff to learn from in the future. We actually already have one that we want to mention, and that's that we cannot stream to the YouTube the camera and the presentation at the same time, so you won't be seeing the speaker at some times. But yeah, we'll figure it out for the next time. But until then, we'll try to make the best of it. Some general info. So we have Slido that you can use throughout the night. If you have any questions, just go to Slido, to this link, and ask the question. I'm guessing you all know how the Slido works by now. Sorry about that. Yeah. So Slido. There's also you can vote for some of the questions there, and the most voted questions will be asked after each presentation. So just go there. There are also some polls prepared, so we might get some interesting data from all of this. So yeah, answer those questions as well. There is, a clear agenda. We're a bit late already, but can we get it to the screen? Yeah, okay. So in a few minutes, we'll start with Robert's presentation. Then we'll continue right away with Hansa's presentation. And after that, we'll have some short break. Michal's presentation and another short break, and presentation of Tejas from Netflix. Some office information for all the people inside of here. So beer is on the tap, as you all know probably, together with some other drinks in the kitchen area. And yeah, if you see some snacks that you want, just grab it. And what else is there? So bathrooms are outside of the office. So on the left, there is women, and on the other side, it's men. And yeah, if there is anything you need help with, just grab any person with the Pipedrive t-shirt, and they will help you out. They can also show you around the office as well, and kind of give you a tour. If you want to talk maybe about the career in Pipedrive engineering, wink wink, there is Jakub, which is head of engineering here in Prague office. So yeah, you might as well just go to him straight away. I think that's it from me. So yeah, let's get to presentations. Robert Rossmann from STRV is here, who is a backend engineer. And the name of his talk is The Surprising and Unexpected GraphQL. Fun fact about Robert is that Robert has a history at STRV of being a bit of shooter, because he several times deleted something that looked unused, but was in fact required for a live project. Since then, the term Robert fix has been used to mean completely destroy. It doesn't sound too much fun to me, but go ahead. Stage is yours.
All right, hey guys. I just want to clarify, it usually really looked completely unused, and usually I checked with someone responsible and they said like, yeah, it's unused, so I deleted it. And a few minutes later they called me and they're like, hey, why is it gone? Like, give it back. And it's like, it's gone, man. So that's fun fact. All right, so today I'll tell you 2 stories about my experiences with GraphQL. One will be a little bit surprising for me, and one not really expected. But honestly, I want to set the stage here, okay? So my knowledge about GraphQL is like, this is the start line, this is me, and this is probably the top. Okay, so I'm really somewhere here. Okay, so don't expect this to be too complex. It's really easy. And if you have hands-on experience or maybe years of hands-on experience, maybe you'll find this obvious, but to me it was quite surprising. So here we go. The first one is the unexpected GraphQL. Let me tell you a little bit of backstory. The project I currently work on that has GraphQL, it's quite simple. It's like our own GraphQL interface, and we are the only consumers, so we don't really care about other clients. So usually when the project started, it was a simple thing, right? There was like a few simple queries, maybe some resolver here and there. But then the project grows and you add more queries and you have more data relations and the models get a little bit more complex. So you start adding data loaders and doing all kinds of weird stuff with it. But to me, for example, when I started on this project, using data loaders felt quite natural. It was very nice because it felt like I can just, delegate this work to a later time. I don't need to like fetch everything and then decide what I need or what I don't need. So data loaders seemed very nice at first. And of course, it seems that if you can actually fetch less data from the database, it should be done quicker, right? Because less data. Right? Yeah, probably right. Yeah, I guess. So let me just show you a little bit of how our current resolvers look like. Ignore the names; they are not important. What's important that this is a data model, the thing at the top, and it has a bunch of things. It's like a previous answers, original answers. All of these are loaded after you actually request some of them. Okay, they are not loaded in advance. They are just like loaded on demand through this data loader. And we use this pattern quite a lot. We use it like, I don't know, 60% of time when we write when we need to fetch some dependency, we use most of the time a data loader for that. And yeah, as I said at first, this seemed like a great idea because less data you load, faster it's gonna be. But we have a problem. We have a serious problem right now. The main page takes 8 seconds to load, and it's like, I don't know if that's okay for you guys, but for me that's like ages. So I don't want that. So I started digging into that. And of course, the first thing you want to check is that you check the network, see if everything's communicating nicely. But the network's fast. There's no problem with the network. So you check your Postgres database. Maybe you check your SQL queries if they are performing well. And yeah, of course, you find some. Like there's quite a lot of queries that need optimizing. So you get into that task and you spend the whole week optimizing the queries. And you are very satisfied because now on average, all the queries are done in 10 milliseconds and you are so happy with it. But we still have a problem. It still takes 6 seconds. So yeah, good job on those 2 seconds, but 6 seconds is still too much for me. I don't know for you. For me, it's too much. So I started digging, I started thinking about this, like what could be going on? And to explain the reason why this is taking so long, let's have a look at our usual relations that we have in our data schemes. So the company that I work for, their part of the business is, to oversimplify it, is to build very custom forms. You might think Google Forms, but very like for a very specific purpose. And as you might imagine, a form might be divided into some sections. Those sections might have some questions, and each question could be translated into multiple languages. And some question might be answered by a simple text, but some of them might have like a pre-made choices, like a picker. And all those choices need to be translated as well. And each of these things has its own relation, its own database model. They are not all bunched up together, but they have a different model. They are separated. So that's good. That's what you want. But here's the problem. You have a main query, like when the customer. Oh, I forgot to mention one thing. Let's go back here. I forgot to mention one thing that from our perspective, the consumer is usually the web, and on the web, you really want the whole deal. You want the form, you want the sections, you want the questions, you want all the choices. So when a customer comes up to our site, the query usually selects everything that you can see here on the screen, right? They are not interested in only the questions. They need the whole thing. So you might be expecting that, I think you might know what the problem will be here, but let me explain. So you have a main query that's like a get me the form that I need to fill in. So GraphQL loads the form. But now it needs to load the sections because we use the data loader for it. So it first loads the form, then it loads the sections, and it waits for the sections. And GraphQL gets the sections. And now it needs to load the questions for those sections. So again, it goes to the database, it loads the questions come in. And then the data loader, again, it needs to load the translations and all the choices. And it's like a ping pong game. It just keeps going left and right, left and right. And this adds a lot of latency to the whole request. So the problem is really that, yeah, all the queries are fast, but if you add up all those network latencies and all those, parsing and Postgres doing its thing, it just really adds up. And for us, it turned out to be quite a lot. Like for you, it might be okay. It really depends on the hierarchy that you have in your models and how you implement them. But yeah, that was our case. So I was really surprised to see that it could have this kind of, for me, it was really unexpected behavior. But then if I look at it now, it seems quite obvious. So I don't know. All right, so let me just show you a simple example of how we, for example, load the form. This is JavaScript. Actually, it's TypeScript, but don't care about that. It's SQLized. You don't need to know that. It's an object relation model, something. Right. So this is what we had before. You load the form, and that's it, and nothing else. And you send it back to GraphQL to do its thing. And our solution that we actually applied to improve the response times was to, I don't know if you can see it, I'm sorry, it's so small. It's basically to preload all the dependencies, all the relations that are usually required, like 99% of the time they are required. So we load them in the same query. Even though we don't know yet at this point, we don't know yet if they are going to be used, but in 99% time they are. So we load all the companies, we load all the sections, all the questions, all the translations, everything. So we send it to one query, we get it into one nice object, we send it back to GraphQL. And then instead of just going directly into data loaders, we first check in those resolvers if we already have the data. And if we have it, we just send it back to the client and we don't go to the database again. And yeah, that improved things quite a lot. So yeah, I mean, for your business needs, it might not make sense because probably maybe your usage patterns are so all over the place that sometimes it's needed, sometimes it's not needed. But if it makes sense, you might want to use this. You might want to fetch all the relations together. And sometimes it might be better to fetch them anyway and then just discard them because, I mean, joining a table is quite cheap in Postgres, so there's very little overhead. So might as well do it. And also we had some asynchronous field resolvers. For example, a company might have a field that says how many employees it has, right? So this is an extra information that you need to fetch from the database. And we didn't pre-compute this field before, so only when it was requested, the resolver actually went to the database and asked for the data. So again, this is yet another request that GraphQL needs to make. So maybe you can actually pre-compute it in advance and not to rely on the resolver itself to compute it. Right, so that was the unexpected. Let's go on to the surprising part of GraphQL. And this was really like multi-layer surprises for me. So let me start from the beginning. So the first surprise was, this is a code sample from our test helper when we write GraphQL queries. It's very simple. The only important part was that when I looked at it for the first time, like this was my first experience with GraphQL, and I had a thought like, if I make a query that I name employees, the test helper actually returns that data wrapped in a nice employees object. So I thought, wait, is it possible to actually send two queries at the same time in the same HTTP request? That would be amazing, right? Because I have seen our web to actually issue new request for each query. And HTTP has a little bit of overhead. So I thought like maybe we could get rid of that. Maybe we could just group all the queries that we need and send it in one HTTP request. But sadly, nope, you can't do that. So at least this was some kind of technical implementation that we had in the test helper. I don't even know why it's there, but it's there. But then I dug a little bit deeper because I was like so interested into this. I really wanted to make this because it seemed like GraphQL could support this scenario. And yeah, then I found out that Apple actually can do it. So it was very interesting. So this was, all right, so the levels of surprise was that first one was the thing that I could do it. Then I had the unpleasant surprise that I couldn't do it. Then I had the pleasant surprise when I found out that there is an alternative. And the alternative is, it's called Apollo Batch HTTP link. It's part of the whole Apollo package. So you could actually use this. And the syntax is a little bit different. So instead of getting the results in an object by the name of the query that you use, you just send an array of queries and you get back an array of results. But it's still the same HTTP request. So yeah, that's awesome. So you can use it. And if you can afford it, sorry, not afford it. If it makes sense for your needs, you can actually speed up your response time of your web quite a lot. But the next level of not so pleasant surprise was the realization that if you batch queries together, the whole batch will be as fast as the slowest query in the batch, right? So that's kind of like, yeah, I was sad about that. I'll be honest with you, but it's obvious. So it makes sense for some use cases where you know, for example, that the queries will be fast enough to actually make sense to batch them together. But sometimes you might want to pick something more heavy on the data loading outside of that batch so that you keep the other parts responsive enough, but some content might actually take longer to load. So it's not a silver bullet. It doesn't fit all scenarios. But I was nicely surprised to see that this is actually something that GraphQL supports. And that was the surprising part. And that's it. That was my experience. Thank you very much. Yeah.
Hello. Yep. Very nice. Very nice presentation. Good job.
Thank you.
Can we get the Slido up? We have one question at least. All right, nice. So let's go just for the evening. We're going with Slido first, just so you know everyone is on the same kind of page, because we have a lot of, I'm guessing we have a lot of users just online watching the stream. So yeah, we'll go through Slido first and then go to some maybe questions from the audience. So yeah, the first question is, how do you fix the slow data loaders problems if you are loading from the REST instead of directly from SQL?
That's a good question. We don't load data from REST, so I don't know. But I don't know. I would probably maybe consider using some kind of cache for the REST responses. I mean, if it can be avoided, like if you know in advance that you are actually going to need this resource, or if you think you are going to need it anyway, maybe you could actually fetch it in advance somehow. I don't know. It really depends on the use case. Because the data loaders that I've seen, or at least that we used, they are really used to fetch something that we own. So usually when you have a REST interface, it's probably something that it's external, I guess. But in this case, I don't know. I would probably try to use some kind of caching mechanism for that. I don't know. I really don't know. It's a good question.
Yeah, I agree. Okay, but I would consider that answer.
Right.
But yeah, we're a bit behind and we don't have any questions on Slido. So let's move on to next presentation, I guess, right?
Okay,
away.
thank you.
Yeah, thank you very much. So next up is Jan Salvet. who is platform team lead at Twisto. And his name of the presentation is Our Learnings from Adopting GraphQL. And fun fact about him is last week he walked 140 kilometers around Mont Blanc. I don't know. It doesn't sound like fun to me either. So I don't know. Yeah. Just give us a minute to set it up, but we should be going in no time. Okay, I think you can start. Yeah. Good luck.
Okay, hi. My name is Jan Salvet, and I'm platform team lead at Twisto. And today I would like to talk about how did we manage to grow from REST API to GraphQL at Twisto, and what did we learn when we scaled the company from one small team to multiple bigger teams. Okay, so I would like to talk about introducing the problem that we had with scaling the GraphQL. Then I would like to describe why did we even choose GraphQL in the first place, what benefits did it brought us. I would like to describe our workflow that we find out works best to solving all those issues. Also, I would like to talk about some best practices that we found out that support this workflow that found out works best with this. And I would specifically want to talk about naming, which is a big part of GraphQL and could cause some friction and problems. So this is one problem that I would talk about. And also, last but not least, I would like to have some time for questions in the end of the presentation. Okay, so let's go. Let me begin. So okay, in the beginning, at Twisto, we had just like one app, which was using a REST API. It was developed just by one team. So it was quite a easiest way to use the REST API. But later, fortunately, the company grew. And now we have 3 apps on 3 different platforms, which was web in React, which was iOS native app, and Android native app. And we also have, instead of just one team, we have multiple cross-functional teams which are shipping features at the same time using the same GraphQL schema. So naturally, there were some issues that need to be solved. So that's what I will talk about. And now let me explain why did we even choose GraphQL as a solution to these problems. Like I said, at first we had just this one mobile app, which had just this one design, and it worked quite well with REST API. But then we wanted to introduce a new React app, which would also work on desktop. So it was completely different layout from the mobile app. So it will be really difficult to pull off this in the REST API because we would have to redo all of our endpoints and include completely different data at the different places. So it would be lots of extra work. So we have decided that the GraphQL could be the solution to this. And also we wanted to iterate more quickly with GraphQL. So that's why we choose it. So let me just reiterate some positives that we found out that GraphQL could bring us. So we wanted to support multiple devices with different designs. So, as I said, both mobile and desktop, which had completely different layouts. We wanted to iterate more quickly, so the front-end guys can actually play with the design and can move things around as they want without any work from backend developers. And we wanted to be able to redesign the app without changing the API, so we don't waste time from my backend guys just changing things because something wants something somewhere else. And also we want to be able to release the features at the different times for each app, so we are not like locked in and the teams don't have to wait for each other just to be able to release the feature at the same time. But when you have like more teams working with the same GraphQL schema, there are some difficulties that you have to solve. Obviously, there are some cooperation needed between the teams working with the same GraphQL schema because they need to know what they are working on, so they not work on the same thing. So they need to be in sync and want to know. They need to know what's happening. You also need to have some consistent naming because from the point of view of the front-end developers, this is just one GraphQL schema. They don't care that there are multiple teams working on it. So the naming should be consistent throughout the API. You also need some consistent style. So for example, when you decide on some type of error handling or something like that, it needs to be consistent throughout the API. Otherwise, it would be really confusing to the front-end guys. And now let me just describe this workflow that we found out works best to cooperate between our teams. So first thing, when someone wants to create a new feature and introduce it in GraphQL, he just creates a pull request with a proposal of the schema changes. This is possible because we have the schema committed in Git repository, which means you don't even need to run the backend app to see the schema. You can just open your GitHub account and see it in the repository. So you just create a pull request and anyone can actually comment on it. So when you have the pull request, the changes, you just notify all of the participating teams, which in our case are all of the front-end teams. Usually just one guy from each team just acknowledges or comments on it. We also use like a dedicated Slack channel for that, but you can use anything you want for it. And it's like, it makes sense because front-end teams can actually comment on that. So if there's something that they don't like, we can actually resolve it before the implementation even begins. So there's not much wasteful work there. And there's like another step, but this is optional. This is only possible in our app because our API is not public. It's only for our own application. So we just instead of implementing the feature, we just commit a completely mock implementation. We just returns fake data instead of proper functionality. And the benefit of this is that the front-end guys can actually start implementing the features before even the backend implementation is finished. So it actually speeds up the whole implementation of the feature. So backend and front-end guys then can start working in parallel to implement the feature. So this really sped up the things for us. Also, when you have some bigger features, it makes sense to just release it under feature flag for some internal testing before it's released to public. In our case, it's just it's a closed group and some colleagues in our company which are using a beta version of the app. And when the thing is without bugs, which almost never is, but anyway, when it passes through the QA and the testing, you just launch the feature. That's it. Okay, now let me talk about some best practices that we find that work best with supporting this workflow and are really useful. So the first one I would like to talk about is, as I said, to have a schema committed in a repository, because this allows anyone who doesn't even have the app running on his laptop to just see what's there and can actually propose changes and comment on it, for example. So Otherwise, you would need to run the app, which is not required there. Also, when you have the schema commit in the repository, it's a good idea to change your continuous integration pipeline to actually verify that the schema that you have committed there is actually valid and matches the code itself, because otherwise what can happen that some developers changes the code and forgets to update the schema, and you will get the schema would get out of sync. So it's a good idea to actually have this check in your CI pipeline to prevent this mistake. Also, when you have GraphQL, I hope you have documentation for it. At least we do. And when you have documentation, it's a good idea to have some linter in your CI pipeline to actually verify that the snippets you have in your GraphQL documentation matches your schema, because otherwise it will automatically prevent like your documentation getting outdated. So it's a good idea to introduce these tools that can parse any markdowns, for example, and find GraphQL snippets and validate it automatically. So this is something that's a really good idea to automate. Okay, and when, for example, you have like multiple front ends with many different like teams developing it and running on different repositories, it's a good idea to actually introduce some additional checks to their CI pipelines to verify that their apps are actually working with the latest schema you have on your backend. So you prevent these mistakes when someone releases the feature prematurely before it is even deployed on the backend. So this is also a really good idea. Also, I would like to add that whenever you make some like guidelines or styles, it's best to have it, documented in your as a part of documentation for developers, because when someone new arrives, it's best to just reference him to this documentation instead of telling him what he did wrong. So, okay. Well, now I would like to talk specifically about naming, because as someone said, like naming is one of the hardest things in computer science, and therefore it's one of the hardest things in GraphQL as well, right? So when we were designing the API and thinking about the names, we just realized like we ask ourselves the question like who interacts the most with the API, and we find out that it's the front-end guys basically, because in our case for backend guys the GraphQL names are just one line of configuration, right? But for the front-end guys, the names are all over the auto-generated code. It's everywhere basically. It's like a huge part of the code base. So it's best just to let them choose the names, because in the past we had we wanted to push some names from naming style from backend to front end, and it led to some really heated discussions, and it wasted everyone's time, and it was not worth it. So basically, it's choose different battle, not let them just choose the names. That's the main takeaway. So also there's like you should not forget about the GraphQL schema, that it should be independent of the design. So you don't need to change the API when you change the design. Otherwise, like you would lose one of the biggest benefits of GraphQL, at least for us. So it's a really good idea to just make it independent. In that way, you can support many different views seamlessly and automatically. And yeah, this is like best practice for designing GraphQL. Okay, this leads me to a conclusion. So with this, with introducing GraphQL and this workflow, we actually were able to have even faster delivery of features with many times bigger teams than before. So to us, it was really worth it. And it allowed us to have a big flexibility with design. So the front-end guys can actually move around things in the app, and it just works. We don't need just to have a help from backend guys to change the API. It's really flexible to us. And also, we can support many different designs on different platforms. So this is something that's really important for us because we support like every possible platform that is there. So okay, that's everything from my presentation. Thank you for your attention. And now we have some time for questions.
Oh, good job. Very nice presentation.
Thank you.
We have a lot of questions for you.
Oh,
So yeah,
did not see that coming.
let's start from the top. So Rostya asks, how exactly does GraphQL help you do the releases on multiple platforms compared to the rest?
Okay, so basically GraphQL allows you to have like different queries from different devices at the same time on different platforms, which would be really hard to do with REST because you have usually just one endpoint for each resource. But you know, we have like different requirements for each app, so this would not be really possible. So GraphQL help us there to just support many different platforms because every platform has different design basically and different requirements. So this is like the area where the GraphQL is most helpful, I think.
Nice. Okay, Martin asks, who reviews and approves PRs with schema changes? Does it need approval from platform team?
Yeah, basically this like the step I mentioned, like proposing the changes, it's just for like general comments, but usually the whole delivery of the PR is up to the delivery team or the cross-functional team. So they do the reviews themselves. So they are those that are responsible for delivering the feature. So no, platform team is not reviewing every pull request that happens in our company. No, not really. That would not be feasible at all.
Makes sense. Does the whole Twisto app run on GraphQL now?
Well, that's a good question. Well, we hope it will someday. No, but really, like it will in very near future. So right now we have both REST and GraphQL, which is something that we found worked best for our use case because we were able to migrate slowly from the REST to GraphQL, with both of them functioning at the same time using the same authentication and stuff. So it was really easy for our front-end guys to just switch.
Yep. All right. Well, this is very straightforward and a quick question, I would say. How do you test it?
Yeah.
Manually, probably. Right?
No, automate everything you can, right? No, but we have some like tests that test like the most queries that contain most of the stuff. But yeah, it's. I mean, what do you mean, like testing GraphQL implementation? Because you know that you should have some unit tests that verifies that the GraphQL implementation is correct, and also the front-end guys should also like have some tests that test that their implementation of GraphQL is correct, and then you have some integration test that actually verifies that the apps itself can connect to real backend and actually communicate correctly. So there's like many layers of the test, I guess, and you should, in the best case, have all of them. Otherwise, you could have some unexpected issues on the production.
Okay, nice. Let's do a last one. So we have enough time, you know, for a break. So have you tried to versioning your GraphQL API?
Oh, we did not actually. We have just one GraphQL API and it just works. But it's a really good idea to, when you like deprecate fields or something, you have to track the usage of the apps. So it's otherwise it could happen that you remove some functionality that is needed, that is actually in use. So it's when you actually do this, when you track the usage of the fields on the resolvers that are there and you just deprecate them after they are not used, and it's not a problem. You can actually keep the schema living and you don't need to version, basically.
Yeah, I think it's kind of anti-pattern or something.
Yeah,
like
it's
that, right?
anti-pattern.
It's not considered a
It's best to
bad,
prevent this
good
issue.
habit. Okay. Well, I think that's it. Let's have a short break for the next presentations. So if you have some questions for Hansa or Robert,
feel free to just grab me and have a beer or something and talk about the technical stuff if you are interested in something like that.
There's plenty of beer, so let's have a break and let's meet in like 10 minutes or something like that, right? Yep.
Okay,
So-
great. Okay.
Hey, hey, hey. Let's go to next presentation. Alrighty. So next up is Michal Sänger, who is principal developer at Pipedrive, here at Pipedrive, and my dear colleague, maybe friend even. And his topic is GraphQL Server Code Generator, which is super interesting. I already heard it. And fun fact about him is for several years he wrote restaurant reviews for all major newspapers in Czech Republic. Mladá fronta dnes, Lidové noviny, and Hospodářské noviny. So if you go to talk to him afterwards, he might tell you something about programming, but probably more about food. So yeah, good luck. Have fun.
So, yeah, now you can hear me. I can hear, you can hear me. So, yeah, I did something into the food scene. You can follow me on Instagram if you are into food porn. And this is apple juice with strange foam on the top. So, hello again, I'm Michal. I work here in Pipedrive and I really like GraphQL. I would like to show you how we are dealing with the GraphQL at scale. And it's gonna be a really sneak peek into what is currently under development. It's kinda experiment, and it's also pretty unconventional approach, so open your mind. And to understand the motivation, I guess I need to show you how it all started. So the part of Pipedrive that is being developed here in Prague is leads. So users can manage their, let's say, business opportunities, which is leads is the shortcut of it. They can filter it, do an infinite scroll. They can open each of these leads and edit, convert, archive, multiple operations. And the interesting part is couple of data comes from different data endpoints. For example, the person there, it's a different endpoint and different microservice. The labels come from some endpoint, the emails here. So that's the situation. And initially it was implemented with the React on a client with Redux. And it's a microservice architecture. So a lot of requests, Redux managing, and as the application grows, it does not scale well. So everyone knows that frontend loves GraphQL. I assume everyone agrees with it. I'm not going into reasons why is that. So actually, GraphQL helped us with the first scalability issue. So we introduced Node.js backend service, the GraphQL. We incorporate the relay into the front-end client. So the GraphQL schema follows the best principles, best practices the relay is recommending, and I recommend if you whatever client you use on the front end, follow the best practices of relay. And it's kind of funny that this simple step is still a big topic in many companies. I constantly hear that they are considering, shall we even go this way? So as I said, let's assume that everyone is on this page and it's solved. So we introduced this backend service, but that doesn't come for free. There are a couple of issues coming out of the manual work. So it costs time and money to build another service. If you get new colleagues in your team, you have to onboard them into new tech stack. You are also obviously building something like technical debt because you are constantly adding new features and the previous ones are a little bit behind. And this brings again the question of scalability. Can it scale? How will it scale if we will gonna add more features? So that's the issues, but kind of organically in Pipedrive, we introduced the GraphQL Federation. It's kind of mainstream approach. You don't want to have one single GraphQL service. You build multiple of those, and you somehow want to federate them into one graph because one GraphQL endpoint is what the front end wants. Yeah, so maybe this could be like the end of story. We have a federation and it works somehow. But again, the federation brings new issues. So the main one is you still have the manual issues over the manual work just multiplied by n, where n is amount of these subgraphs you are maintaining. Then there is a question about the schema design and the ownership. Who should build which part of the schema? How to reuse these principles and types if you want to use them. Who should, for example, build and maintain the node query, which is pretty useful from the client point of view. And actually, will it scale? Because it brings extra complexity. So how to deal with it? Obviously, you can expect you will need more backend developers. And if front-end developers want something into the schema, they have to talk to these backend developers so they can implement it for them. So these are kind of obvious issues, and you somehow need to deal with it. So I was like thinking about, are there any alternatives? And when I was thinking, I was also watching YouTube. And there is awesome talk by Adam Kramer, who is a member of the GraphQL platform team at Facebook. And he had a nice talk about how the GraphQL at Facebook is being developed. And he has also a wonderful talk about managing massive schemas with CodeGen in Facebook. And the very interesting idea is Facebook doesn't write their GraphQL service at all. They have the backend, and they just annotate or describe what properties should be propagated to the GraphQL schema. That's interesting idea. Dramatic pose. And the huge benefit out of it is it's really simple to introduce something into the GraphQL schema. Basically, every developer can create a pull request that somehow adds that annotation, and part of the backend model is propagated to the GraphQL schema. So the biggest idea out of it is automate all the things, which kind of resonates with the smart word by some smart famous developer. I forget his name, but that is the code easiest to maintain is the code that was never written. But if you have this idea, you would somehow like to automate, create the service automatically. How to do it incrementally, because we already have the federation. So the overview of the whole idea is, if we are able to start small and somehow automate and generate one of these subgraphs, one of these federatable GraphQL services, we can integrate it in the current infrastructure and see how it behaves and somehow iterate on it. And if it's convenient to use, probably that generated service will grow, more developers would like to use it, and maybe even some services can be these GraphQL services can be deprecated, and the final stage could be we won't need a federation at all because we will be able to generate the whole graph just like that. So if we don't need federation, couple of issues and the complexity will be reduced. Then comes the question, how to automate? Easy to say, but how? And you can immediately come up with two approaches. You can think about, yeah, I want to have some config. I will create some code, and this together will be an application that will run in the runtime and somehow behaves as the GraphQL service. And then you have to deal with the errors in the runtime, and you have to somehow imagine you are committing changes into the config. How do you decide that these changes will actually work? Because all the rest is happening in the runtime. The code somehow takes the config and act based on it. It's not a simple thing to reason about. Then is the second approach, again inspired by the Facebook, which is you have some config or some annotations, you have the code gen, something that takes the config and generates the code as you would write it. And that's kind of mind shift, because usually you are not used to write code that writes the code. You just write the code and run it. But if you can generate the code as if you wrote it, it's kind of a huge boost to your productivity. So we picked that way with config and code gen, and our objectives here are we have to provide great developer experience, because developer experience brings developers that would like to use it. And if we produce a human readable code, we can still stay with code review and all the processes that we have, which is alignment with processes, because we are good with dealing pull requests. We can run the continuous integration, all the tests, everything on the generated code as we would do normally with the manually written code. So how to generate the human readable code? It's like when you think about it, it's not that simple maybe, but then you realize we probably do it every day actually, because when we are using Prettier and we are using ESLint and we have the Babel, we are actually doing it. You can write a spic and the Prettier will make a beautiful output out of it. And the Babel is awesome, powerful tool that gives you way how to generate the code. So at the end you have the TypeScript output, and maybe this is the way. So what features we want to support with this generated code? We want to have automatic pagination because we follow the relay cursor-based pagination. We have a global ID because global ID is great for the node query, and node query is great for simpler schema, and the front end can automate with that query a lot of things. We want to use data loaders, and we want to introduce some common scalars, mostly for daytimes, for example. And another great feature we want to have is a mocking, because mocking is a great thing for fast prototyping. And here we come with example how quickly you can build a GraphQL service that provides some mocked data. So we have a config, yep. And here you can see that you define some types. Actually, here we have just a one type. It's called user, and it has some fields, ID, name, and an email. Both are of type string, and you call some mocking or faker library methods called full name and email. And then you have a data loader that where you just say, hey, this data loader will provide some mock data through that helper. And in queries of that config, you define there is going to be users query, which gives you a list of users. And again, it's going to be mocked. With this config, you can just call the tool, the code gen itself, and you say, generate the output to my service folder. And when you go to the my service folder, you get the whole service there. And you can see you get a couple of files, basically something you would write manually if you would be implementing that server, just much more faster. So yeah, if you run that service, you can throw this query. Yeah, so this is the pagination with cursor and that thing. So you get some data. Note that these global IDs and the cursor, this is something you get for free. And because we have also ID as an we have a ID field defined as non-null ID, we also get a node query for free. So you can use that ID to get the detail of the user, and you immediately have a running GraphQL service. Your client can immediately, your front-end developers can immediately start using, and that's kind of huge boost in productivity. And once you have your backend ready, you can remove these mocks and start returning real data. Here you can see that the data loader, instead of mock, start using some data source with a REST API endpoint. And you get a new field where I want to show you how easy it is to rename something that's coming from the REST API, but you wanted to have it in your schema a little bit renamed. So instead of returning last_login, you want to have last login in a camel case in your schema. And that can be done easily just by the config. And you add some useful description, which is always very beneficial if you add in your schema. And that brings me to interesting point, because the more REST API services you start using, the sooner you realize that it's a wild rest out there. Actually, every service is a little bit different, and tons of small differences makes usage of some like generic generated code very difficult to use. If you want to have some example, let's see that we have another schema with user and tasks. So you define a user, ID, name, some score as end, and a list of user tasks taken from some data source. And then you have a task with ID and title coming from a different data source. But the user data source gives you something like this. If you don't have the score, it's not a null, but it's a string unknown. For some legacy reasons, whatever, you got this response. What can you do with it? And the tasks are not IDs, but some URLs to some API endpoints. That's how the data are coming. What can you do with it if you want to have your code generated? Because the data loader expects IDs, but you get URLs. And that brings me to the most powerful feature of the code gen, which is plugins. So you can easily define a plugin to the generated, one of these generated files can be, when it's generated, it can be modified with a plugin. So if you remember, we get a couple of files for each feature defined in the schema, and one of them is the mapper. And mapper is basically a function that is called after the data are fetched from the REST API. You want somehow map the response to the internal shape you are working with your resolvers. So we need to modify the mapper. And actually the generated code of the mapper is kind of stupid. It does nothing. It just accepts the data and return the data. Because when it's needed, it expects to be modified. And how it can be modified, it's again the wonderful, powerful tool called Babel. You just provide a Babel plugin that, if you are not familiar with the Babel plugins, it basically works like this. Babel lets you work. It's called a visitor pattern, and it basically tells you, give me an object with a couple of defined functions, and if the function is matching with the line I'm currently processing, I call that function, and you can alter the code of that line. So what we need to do here is we have to find the return statement. Then we create with a Babel template some different code. We create a TypeScript expression, and we can insert that expression before the return itself. And that way we get from code before this one after. So we were able to modify not so useful response of the REST API into something useful and reusable. So this way you are basically open to change whatever you want when you need it. But if the REST API somehow is aligned with your GraphQL schema, you don't need these plugins at all. So just to give you the overview of the development, how we think we will soon use in Pipedrive, it's like every developer can modify the config. It's really simple. Hopefully you saw it in these examples. Sometimes you need plugins when the REST API is not well aligned with your schema and client expectations. But then you just run the code gen, you get a code which you create pull request, you send it to your GitHub, your colleagues can review it, your continuous integration can run all the static analysis, tests, whatever you use. And if it's fine, you deploy it. That's it. So that way, you probably, or we think, we will be able to build the whole GraphQL service just with this thing, and we probably won't need the federation at all. Yep, so this was the peek into our kitchen. We are really working on it, and it's my daily job to develop it. It's really work in progress. It's an experiment. Maybe it will fail, and my next talk will be about how we failed with GraphQL server codegen. Anyway, I would love to hear your opinion and at least wish us luck. Thanks for your attention.
Cool. I'm just glad you were watching YouTube and not some other video platforms when you were thinking.
Which video platform?
Vimeo. So yeah, let's get to questions. So we have a few of them, and the first one is, well, kind of obvious. Is there a codegen project production ready, and will it be open source?
Yeah, define production ready. As I said, it's currently under development. We work in the development in Pipedrive is being organized as a mission. So currently there is ongoing mission. We are trying to use the tool, and we will see within the mission how it goes. So definitely not yet open source. The question is how to open source it if the output of the codegen currently is a service that is being used in Pipedrive. It definitely has a potential, but it's extra work to make it easy to modify to different surveys, different server implementations, and whatever. Maybe if you are interested in that code, join Pipedrive and you can work on it.
Nice. Uh, the next one is this a monolithic config for all the teams, or each team has config and it's been put it together in one app at some build stage?
Good question. Currently, it's basically monolithic config, but of course the next level is probably every microservice could somehow publish its own piece of the config that can be somehow gathered together, validated, everything. But currently, to start small, we are thinking about one single config. Of course, it's a JavaScript or TypeScript, so you can import parts of it. But currently, single config approach.
Okay, then Anonymous is asking, what's faster, learning CodeGen config or adding GraphQL by yourself?
Faster. I would say, I'm fan of CodeGen, so I would say it's definitely faster to add something into the config, and it definitely scales better. You have to just, if you're onboarding someone into the CodeGen, you have to explain him a couple of things in the config. It can be more complicated to teach someone how to write Babel plugins, but that's, again, not something that's required. And the optimistic expectation is we will need just a couple of these plugins just basically to handle different variations of our REST APIs, and others can just reuse it. So I think it's definitely faster to start with the CodeGen once it's finished.
Okay, and let's have a last question. Vem, I think Vem has had a last question last time as well. So we'll just be ending with your questions today. How do you keep up with changes? Is it working when you adjust your API?
I'm not sure I understand. So you mean, if you change something on your API, and you need to deal with the changes in your GraphQL schema. That's a problem, and it would be definitely better if the config is part of the microservice itself. Currently, I think we will deal with it with something like end-to-end tests or something like that. If backend is somehow changing something that's published without proper notification of their users, that's issue. But if you have the config, you can quickly check if some part of your response is being used and act according to that. That's probably the answer.
Nice. Okay. Thank you very much. Very nice presentation. And yeah, let's have a short break before the last presentation that we have today, which is going to be remote from California, as I understand. Yeah, let's have a 10-minute break. Grab a beer, talk to Michal, whatever. to bring up Tejas to the screen. Nice. Nice. Okay, we can see the presentation, we can see you, everything. So yeah, next up is Tejas Shikhare. I'm really sorry if I'm butchering your name. So you're just repeated the correct way. Yeah, so he's connected all the way from California, as I understand. And he's a senior software engineer in Netflix. And the name of his talk is GraphQL Federation at Netflix. And fun fact about him is he grew up on the equator in Singapore, where temperature is always more than 28 degrees, but his favorite sport is skiing. You can start now. Good luck and have fun.
Thank you. Can you all hear me? Just a sound check.
Yep, well, all good.
Sounds good. Good evening, everyone. I'm from coming to you from sunny California, and I'm hoping to present to you today about our GraphQL Federation project at Netflix. So my name is Tejas Shikhare, and I'm a senior software engineer at Netflix. For the past 2 years, I've been working on building the federated GraphQL platform with a wonderful team here, and I'm excited to share our journey with you all today. So the agenda for today is going to be, most of you might already be familiar with GraphQL Federation, but I'll start with a brief intro. Next, I'll talk about our journey building it, wins and challenges and trade-offs, wins of building some with federated, and also lastly, if the investment is worth it for you. So let's jump right into it. So you might expect in the early days of a company, we might have a simple client with a server and a monolithic architecture talking to the database. But then as the companies grow, the user grow, and features grow, we might start breaking into multiple services so that more than one, a larger team of backend developers can contribute to it. So this is good. But it creates problems for the client. They have to integrate with multiple backend systems. And this is where GraphQL came along and was a really nice fit. It provided the API that the client needed, and it aggregated data from microservice architecture. This is a very popular architecture and very much used at Netflix. And then we might have multiple GraphQL services to serve different use cases. And then over time, the idea of one graph having often implemented as a GraphQL monolith was popularized by Apollo in the integrity principles. There's a one graph used in many places in the industry. And it worked really well because it created leverage and reduced the duplication, and you gave like one API that the client needed. And eventually this GraphQL started growing and growing as more features were added and became our new monolith. And oftentimes it's implemented by one GraphQL team. So every time a new feature was added, we would do code change in both the microservices and the GraphQL layer. And oftentimes this was by a different team. So it required collaboration, meeting to make the change happen. Also, the GraphQL team may have to become experts in many domains because you might have a lot of different domains within the company, and it's all exposed through a single API. Also, first line of support for a lot of the upstream issues. If there's some issue in the upstream, the consumer of the API is going to first reach out to the GraphQL team and ask what's going on. As the graph grows bigger, the code goes bigger, you add more dependencies for external libraries, generated clients if you have gRPC or Thrift or something like that. And as a result of those dependencies, whenever they're updated, new code comes in, potentially causing failure. And if you have this GraphQL monolith, you have a lot of frequent code changes pretty much every day. And if every new feature has to go through this layer. And lastly, cascading failures too, so that whenever if a bug or a memory leak is introduced in one resolver, it could cascade to a completely unrelated thing. And so since this talk is about GraphQL Federation, I'm going to talk about how introduce GraphQL Federation a bit and see how it motivates to solve some of these problems. So the key value proposition of GraphQL Federation is to distribute the ownership of the GraphQL API. And the core ideas behind it is this federated type, which is the ability to extend the type across the service boundary, and then ability to hydrate that federated type. So what do I mean by that? So in a monolith, we might have this movie type, which has personalized title, image, and runtime in seconds, and they might be all coming from different services in the backend. So when we move this movie to a federated type, we might want to have a type that extends across the service boundary, so movie extended across images and runtime. And then each of these services provides the field they own in the type. And then so the key thing here is all of these services know about the ID, so it's the primary key of the type, and they all agree on it, and hydrates the field it owns. And this is the core kind of idea behind federation, having this federated type. And first Apollo kind of popularized it with the Apollo Federation specification. But then there was also other implementations. For example, the folks at Atlassian have a similar thing called NATO, which is in essence the same concept, but a different syntax as the Apollo Federation. And with the ability to federate a type, we envision this architecture where we have these different services is what we call DGSs, this domain graph service. And these are standalone GraphQL spec compliant services that are having a type that is extended across service boundary. There's a GraphQL gateway. The GraphQL gateway exposes the client schema, and it provides, clients' queries come into the gateway. And then the gateway then splits the queries into subqueries, and it goes to the different services. The schema registry is a workflow component that makes sure that the schemas of all these domain graph services can merge together to form a valid schema. And check it out in more detail. Like if you're interested in the technical detail, we have a blog post and also a QCon talk that two of my colleagues did that was excellent. So feel free to dig into that. So let's jump into Netflix's journey implementing GraphQL Federation. So at Netflix, we have two primary graph API technologies. I want to say, Falcor, which was actually invented at Netflix, and GraphQL. So if you're browsing Netflix and you're deciding what movie to watch and you can't figure it out when you're on that UI is probably powered by Falcor. And then we have a new organization within Netflix called Studio, which is using GraphQL. And they're really similar to each other. It just, they were invented at the same time around, and GraphQL caught on in the open source world. So around in early 2019, we saw that the GraphQL monolith in Studio was growing pretty rapidly. And it was about, facing some of the bottlenecks that I touched on in the earlier slide. And we proposed the Studio Edge architecture similar to the diagram I showed earlier with the gateway, registry, and the DGSs components, the domain graph service. And around the same time, Apollo also released the Federation specification. So this was and we saw that, and we were really excited that we thought it was a really good fit for what we were thinking within Netflix. And then, we got a green light for the Studio Edge architecture, and we also started collaborating with Apollo. We didn't, at the time, their gateway was implemented in TypeScript, which was not a good fit for us because most of our stack is in the JVM. So we rewrote the gateway in Kotlin and integrated with all our internal observability systems and so on. And to do this, we had two core teams, the Federation team, which is my team, and the developer experience team, whose goal was to make GraphQL development easy at Netflix. We had volunteer resources across security, observability, and schema governance to make this easier. And this, imagine about 10 people working full-time on this project. About 6 months to a year later, we had a first MVP ready of this platform, and we started working on adoption and migration. So the first step was to take the GraphQL monolith we had and make it the first DGS under the gateway. And then we started chipping that DGS into different DGSs, like movie. So we took out the movie type, put it in movie service, took out the production type, put it in production service, and so on. And we did this without affecting any of the client API. So essentially, the clients were still executing the same query. Instead of going to the monolith, it started going to the domain graph services. Built out developer education, documentation, and then initially we didn't have full spec compliance with GraphQL, so we worked on that as well. And now, 2021 and beyond, we're thinking of expanding. This architecture has been successful for the studio organization, and we're thinking of how we can expand this to Netflix API. So Netflix API is built in Filecore, and we first need to move it to GraphQL before we can apply this architecture. And then also we have a lot of internal tools. You might have heard of Spinnaker and some of these things that are open source, which are using REST right now, but could be moved to GraphQL. So there's the idea of Enterprise Edge, which could power some of the internal tools at Netflix, such as Spinnaker, customer support, etc. And then you're also looking at solving for federation challenges that I'll cover in a second. So what are the wins of the federated architecture? So first and foremost, Netflix Studio is powered by GraphQL. So just to give you an idea of what the studio is, think of the studio organization as like hundreds of services and 60 plus applications that, these applications are used by our studio folks who work in the studio. So think of like different processes like movie production, post-production, visual effects, etc. And basically the applications help to streamline this workflow. So these APIs are now largely powered by GraphQL across the organization. And Federation has been fully live for Studio for over a year now. The second thing also is the federated architecture definitely delivered on the promise of faster product evolution. So I pulled the stats from production last week. So we have about over 2,000 object types, over 600 queries, and over 900 mutations, and implemented in over 56,000 lines of schema. And this would not have been possible for one GraphQL team to implement by themselves. We had hundreds of engineers contributing to this across 90 DGSs. And I would say it was not alone the federated architecture that made this possible. There were a few other things. So first, I think since the ownership of the API is distributed, now many engineers within the organization have to learn GraphQL. So investment in developer education is key. And I think Dev Bootcamp for Federation, and also a lot of example code for GraphQL development that developers could copy and paste to bootstrap their services. Additionally, our developer experience team also created this is open source, the DGS framework, where you can build Spring Boot, Java, Kotlin, GraphQL services very easily. And this integrated with all of the Netflix's cross-cutting concerns across observability, metrics, etc. And developers can now just focus on writing the GraphQL application. We also created a UI in front of our registry, which showed all the different services, their schemas, the schema changes that were happening, and also support links so that people can reach out to the teams where if they had an issue with the schema or the API. And also, Netflix has a lot of legacy applications implemented in REST, gRPC, and etc. And what the federated architecture allowed was we could just convert some of these existing applications to Power GraphQL and then start contributing to the graph. So this allows us to modernize legacy applications and put them in federated GraphQL. Another big win was reduce operational burden in the GraphQL team. One of the biggest challenges we faced when when my team was owning the GraphQL monolith was we spent so much time on support issues. And now the consumers of API can directly reach out to the team that owns the API. And this is possible in a few ways. So let's say I write a query as a consumer of the API and I get back this error. In the error, there is a location of the DGS where the error happened. So in this case, the error happened in image DGS. And also the subquery to that DGS that failed. Now I can take this information, go to the images DGS team through the Slack channel and ask them, like, what's going on? Can you help me with this issue? Another thing is also we integrated a lot of these components from the top gateway all the way to the lowest microservice with our distributed tracing system that the Netflix telemetry team implements. And essentially, it also showed you where the error happened. So in this case, this is yellow, and there seems to be some kind of issue. So you can click through it, look at the logs, and so on and so forth. You can go reach out to the team. And also, if you're debugging a latency issue, we had a Zipkin trace where you can identify where exactly the time was spent. It showed you precisely, and then maybe you forgot to implement a data loader. Let's go find the team who did do that. And also, I think for every request, HTTP request, we also emit metrics to our server. So we actually augmented these metrics with some GraphQL tags. So like what type of operation it is, query, mutation, subscription, the operation name, and the query hash. And this allowed us to then segment our metrics. When I was looking at debugging some issue, you can segment them by what query was affected. And then you can see all the queries that were happening in production. So all of these things helped and showed that the wins. But like with any architecture, there's always challenges and trade-offs. So let's jump right into it. And the first one is schema management is hard. And I think you have seen across many of the talks in this meetup that this is a pretty hard problem. So we had to get ahead of it by forming the schema work. We got ahead of it by forming the schema working group. And we had 3 goals: review the schema changes that were happening, help with the schema migration from the monolith to federated architecture, and also create best practices for schema design across pagination, error handling, and so forth. But we quickly realized it was hard to scale the schema group as the API started to grow. The API was growing much more quicker, and since so many people were working on it. So initially, we tried to review every schema change, but then the graph started growing, and we pivoted towards reviewing only like new services and focus our energies on the core shared federated types. Netflix also has a culture of freedom and responsibility. So it was hard to enforce like a review process. I think a lot of teams tried their best to do it, but sometimes they would review changes within their teams and just push it out. And also the best practices were hard to enforce. So this is something that we're still working through, thinking about how we can make this process better through tooling or new ideas that will help collaboration become better. The large one graph also posed a problem. So many developers were building schema in isolation. And although it wasn't as bad as before with the microservices, we did see some duplication in similar functionality. And this was largely because the developers weren't really talking to each other as much. Name collisions are inevitable. And as you saw earlier, we had like over 2,000 types and 1,500 fields of root types, and they all live in a global namespace. So you have to think of some namespacing practices or consistent naming or logical naming. So we went with this approach for our studio side, where there was a lot of different teams. So for example, here I've shown an example. We have a protocol suite of applications that help with the production of a movie, while we have Hubble, which does talent management. So how can you discover these APIs even in the graphical window easily? So we wanted to make it easy to search. This did affect the code gen a little bit on the client side, but there was a trade-off that had to be made here. And you have to kind of decide this for your own organization. Error handling is another area. So error handling is already pretty vague in GraphQL spec, and federation amplifies those challenges even more. So let's say, there's a couple of many ways to do errors in GraphQL. So let's say I have this simple query user, and I give it a bad user ID. I could either have it in the errors block with not found, or I can create an object and model it in the schema. To support the errors block scenario, we created a spec and mapped all of the common HTTP codes to a classification, and then built automated tooling around this, so that people can throw those exceptions, and this would be automatically populated. But even then, it was difficult to enforce. And largely, the error handling was pretty inconsistent. And this actually, in turn, affected the clients because they weren't able to reuse their existing error handling code across use cases. Product-driven API is another big one, where historically, GraphQL was designed for the clients. And this is a quote from the Wikipedia GraphQL. But it's the reality is the federated architecture does bring the GraphQL API closer to the backend. And how do we work around some of those challenges? So how do we prevent GraphQL from looking like the service model? So one idea was we have a schema-first design that has worked well for us. There's some extra boilerplate mapping code between the service types and the schema types, but it keeps the schema models independent and they can evolve independently. Code-first schema is also fine as long as you have a separate set of models from your service models. And then the new thing we're thinking about is how can we have more UI client developers contribute to the graph directly? So they're already involved in the schema design process, but what if they want to actually contribute to the schema? So we're thinking of maybe a serverless platform for domain graph services, somewhere. So this is like more future thinking. Security is another area. So in a federated architecture, it's really easy for anyone to expose a new field or a query to the outside world. And having the right set of authorization is extremely important. Having a centralized ODSI system can help, as you can declaratively define policies for the new fields you add. And also, you probably want some kind of a default authorization policy, because when new services are coming up, you might forget to set up the authorization for some fields and accidentally expose data to unauthorized users. Some kind of audit system or penetration testing can also help to make sure that you're not leaking unauthorized data. So security should be forefront because it makes it so easy to expose an API in production. Some new challenges. So now currently we are migrating the Netflix API experience to GraphQL and GraphQL Federation. So some of the challenges we are thinking about is A/B testing. So we do a lot of A/B testing and iterative product improvements. And how can we do that well with GraphQL and federated architecture? A lot of the A/B tests fail and result in a lot of deprecated fields. So how can we have a cleaner deprecation flow for failed A/B tests? We're thinking of using something like an experimental directive, which is already something that's deprecated and has an easier deprecation workflow. But that's something we need to iterate on. Another challenge is multi-platform. So Netflix has 4 UI platforms: the mobile platform, the TV platform, and they all have different use cases. So the mobile platforms have lower connectivity, but a large amount of RAM, while TV has always connected to Wi-Fi, but less amount of RAM. So we might have to think about different pagination schemes. We have different partial error handling. So how can we use the same API, define one API for all these platforms? So this is something we're also working on. And then lastly, there's also an idea of server-driven UI within GraphQL. This is a big, interesting area. And we're thinking about how to do that as well in the federated world. A few things, we use Apollo Federation spec. So there's some spec compliance stuff and miscellaneous issues with Apollo Federation that we're working Apollo closely with. One example is if you have a monolith schema with polymorphic types. So if you have a lot, then it will be more complex to migrate to federation. So what do I mean by that? So let's say we take that example from earlier with the movie where we split it up into 3 services. What if it had implemented an interface in video? Now splitting that up becomes a little bit more challenging because this by itself is not valid according to a standalone GraphQL server. So this is a challenge. Another challenge is evolving shared value types. So before I talk about what a value type is, we know what a federated type is. So a federated type is a shared type across services where each service kind of provides certain fields on the federated type. Value types are another kind of a shared type, which is, I like to use the example of page info. So if you use relay pagination, you might have this common object that you're using in multiple services. Paginating movies or paginating talent, and the structure of this object is same, right? So we want to be able to share this across, and it's possible. But what happens is when you try to change this type, let's say if I try to add a field and it's used in 10 different services, how am I going to deploy those services all at the same time so that this type is valid across the entire ecosystem? So this is another challenge we are working on and hoping to come to a solution. But there are challenges with any architecture, and I think the long-term goal, I want to kind of cover the last part, is it worth it for you? So this is a pretty early stage in maturity lifecycle. I think Apollo is doing a fantastic job with their offering, but there are several trade-offs and challenges that need to be addressed. It is a time and resource-intensive investment. And I think we also partially got lucky in our organization because we had a lot of champions for this architecture. Excitement was high, which made it successful. But you have to navigate this in your organization. Some other questions to ask if you're considering a federated architecture is, do you have a robust microservice architecture in your organization? Federation might be a really good fit. Has GraphQL monolith reached the critical mass for federation to make sense? How many developers and federated services do you expect to have? Is it going to be hundreds? Then maybe federation is awesome fit. But if it's only going to be a handful of services, you might want to consider keeping your GraphQL monolith. And lastly, I want to bring this slide back. And I showed all these bottlenecks at the beginning. And I said federation solves most of them. But it is not impossible to solve these without federation, right? We don't need federation to solve this. So for instance, we can take some of the concepts of distributed tracing and error handling and make sure that the GraphQL team is not the first line of support. We can also create a way for multiple teams to contribute to the GraphQL API. followed by, if there's frequent code changes, you can solve by canarying them in production. So by canarying them, you can expose a small portion of traffic to the new code. And then once that's all good, you can say, okay, I'm gonna ship this out. That way you can avoid outages. And then cascading failures can also be solved by functionally sharding the same app, but deploying it to different shards for different use cases. So one use case does not cascade to other use cases. So there are a lot of strategies to solve these problems. And with that, I hope this gives you a glimpse into the journey federating GraphQL at Netflix, how we started, how it's going. And I hope I'm really excited about the GraphQL, but also about how federation happens on GraphQL. And lastly, I would like to thank all the wonderful folks here at Pipedrive for giving me an opportunity to present here. Thank you.
Thanks. Thank you. So yeah, thank you very much. There was a lot of clapping. I'm not sure if you could hear it. Can you hear me?
Yeah, I can. Sorry.
Perfect. Nice. So yeah, a lot of clapping. Very good job. And yeah, we have plenty of questions for you. And yeah, we have a lot of questions from Artyom Kurapov. I can tell you it's all the way from Tallinn, Estonia. And yeah, so do you implement node query in your federation gateway? Any issues with that?
Yeah, actually we do. So this is a little bit of a interesting use case. So by node you mean the object identification, right? Just to clarify, the relay object identification spec. Yeah. So in one of the slides, I show you how we have to hydrate the federated type. So essentially, there's a concept of this thing called entity resolvers that exist within Apollo Federation that you can use to hydrate. So basically, what we do is we automatically generate for every federated type a node type. So we have this and this is automatically generated on the gateway. And so we extend that federated type, and based on the key fields, so you can have a composite key for the federated type, we encode a global ID for it. And the logic for encoding so the key fields are like all the fields in the federated type, right? We take those fields, we concatenate them, and we encode them into a global ID. And then that global ID can be used to look up all of the federated types automatically. So this all works out of the box. So as long as any developer defines the node type, it will automatically become, if any developer defines a federated type, it will automatically become a node in our service. Does that make sense? And yeah.
Yeah, I think it does. Any issues with that though?
No, so far we haven't ran into any issues, and actually it really helps with client-side caching, because so let's say if you have a query that you did, and then you only want to refresh that one particular view in your client, and you only want to look up a part of it, and oftentimes it's just one particular type, then the node query is really useful for that. So it's been working really well.
Okay, thank you. Let's get to the next one. So Tomasz is asking, do any of your services use Golang? If so, is there any package supporting federation similar way like your implementation in Kotlin?
So unfortunately, we don't have anything in Golang. Most of our stuff is most of our federated services are in Java and Kotlin, and then JavaScript. So I'm sure, though, I think since we use Apollo's federation spec, and one of the reasons we use Apollo's federation spec is since it's very broadly used in the community, I'm sure there is something that actually is available for Golang by now. I would have to probably look it up, but I'm sure there's a federation package for Go.
Okay. I'm not sure about that. I think we had some issues with that one. But yeah, it doesn't matter. So let's go to the next one. Do your services register their schema in runtime or in compile build time?
Yeah, this is a really great question. So actually, we think of the services that are running. They're independent of what the gateway is doing. So the services are built and deployed independently, and then there is plugins and pipelines. So plugins allow you to push the schema to the registry, and you can do that before you deploy your service, or you can do it as part of the deployment pipeline. But it's completely independent. And what we try to do is we try to deploy the service first, because most of the changes are backwards compatible. So you're adding new fields, so you can deploy them to your individual GraphQL service, and the gateway still doesn't know about them. But once they're deployed successfully, then you can push the schema up, and then the gateway knows about them. But the thing is, it doesn't really matter, because any new field you introduce, it's not going to be used right away. It's going to be used after a certain amount of time. So there's a gymnastics that needs to happen there, but I think what we're doing is working well for us so far.
All right. And another question from Artyom. And so any plans to open source your gateway or schema registry? Maybe collaborate on Pipedrive GraphQL schema registry, which is open source, as I understand.
Yeah, I mean, this is always on top of our mind. I think especially the gateway stuff is fairly open sourceable, considering it's a rewrite of the Apollo's TypeScript implementation, and we've built on some new things on it. But I think we've considered doing that. We just haven't had the time or the resources to make it happen. The schema registry, however, is built in a way it's fairly tied to our data system inside. So we have to do a lot of work, refactoring work, to make it generic so that you can try it to like any data system. So that will be a lot more effort to open source. But the gateway is certainly at the top of our mind, and maybe we will do it in the next year or so.
All right, looking forward to that. Tomasz is asking, are you by any chance using gRPC as a communication channel between DGS and gateway?
Right now, we are not doing that in production, but we're doing some experiments with it, particularly, but not in production. And maybe if there's a more follow-up detail, we can discuss offline, like what the reason would be.
Okay, I guess we can give Tomasz your email address or something. So yeah, another one from Artyom. So I noticed subscriptions in your slide. Do you reference main entities in subscriptions too, or only event data?
Yeah, so we do, and this is essentially subscription. The field itself is tied to one DGS usually, and the event is processed by that DGS, and then you can actually hydrate. After that, it's just a query to hydrate whatever field that subscription, whatever type that subscription returns. So yeah, we have full spec compliance on subscription. The hydration of federated types implementation is in progress, but it will be spec compliant by pretty soon.
Okay, works for me. Is UI for end users, meaning us in the audience, using the GraphQL federation as well?
Yeah, the UI is actually powered by a monolith GraphQL API, but as I said, it's just a monolith GraphQL service. And like I said, you know how we're thinking about moving GraphQL federation to our internal tools. So in the future, we can expect this monolith to be one of the DGSs inside the enterprise edge that I talked about.
Yep. And another 3 questions from Artyom. he's very curious. Do you limit query complexity?
We have static query complexity implemented, but we haven't seen the need to turn it on yet. But I think as we launch it for the Netflix API, we might have, because that's a more public API. the studio API is authenticated. So you need to have work in one of our studios, or have reason to access that API. There's a fair number of people who have access to it, but we haven't seen any reason for turning on query complexity yet. But it is built into the gateway.
Okay. Did you have any incidents when gateway or schema registry was down? Do you use it in internal network private requests too?
Yeah, certainly. So schema registry is actually, like, I like to think about the gateway as the highly available component of the system, and the schema registry as the workflow component. So certainly, like, the registry should not be doesn't need to be as highly available. So what we actually do is we have the registry create an artifact that is stored in S3. Essentially, every time a schema change happens, and then the gateway only needs that artifact to run by itself. So we try to decouple the gateway from the registry by having this extra layer of resilience in between. Was that the question, or did I misunderstand it?
Yeah, I don't know. Well,
so
yeah,
we have had a couple of incidents, but they were fairly on the gateway side, where since we talked to so many DGSs, but they were related to dependency management, but nothing major from the architecture itself.
Okay, yeah, I think we can connect you and Artyom as well. But yeah, we have two more questions. Is it? Yeah. And this is a funny one. So, are you aware of any Easter egg in Netflix UI?
Let's see. There's a lot of stuff that happens in the Netflix UI. I mean, if you're in Poland, you can access the new Netflix games tab on the UI and check it out. But you have to go to Poland for that.
So VPN to Poland, you say?
Yep.
Cool. Okay. And last one from Artyom as well. You're best friends by now. So do you register API consumers for tracing schema usages and deprecation? How do you analyze its usage?
Yeah, sure. So what we do right now for that is we take for each query document that the gateway gets, and this is only on the studio side. We'll need a more scalable, because the traffic is significantly higher on the Netflix API side. But on the studio side, what we do is every query document, we log it to Elasticsearch, and then count what fields are used over there, and then basically keep track of join them with the deprecated fields and see if there's any deprecated field usage stats, and we actually show them on the registry UI, and then that way, when developers are going through the deprecation workflow, they can deprecate the field, and then they can notify the clients saying we should remove the deprecated fields, and when the usage goes to 0, they can then make a backwards incompatible change to remove it from the API.
All right, I think that's it for today. Finally, so thank you very much. That was fun, and yeah, have a good night for us, but good day for you. And yeah, that's it. Thank you very much.
Thank you all for. It was wonderful.
Okay, so I guess that's pretty much it for mainly for the online users, because that's the end of our plan. We have some feedback form that we'll send you out. So if you want to spend a few minutes, helping us out, improving the next event, it's it's gonna help us out. So please do that, and yeah. That's it. I think we can turn off the online stream now. So yeah. But for everyone in the office, we're not closing. I think beer is there or on the way. It's here. Okay. So more beer is here, and yeah, the party continues. So